This is Unit 8, Lesson 4, about dilations. So the bell ringer, to start out with, asks you to look at this figure that has been rotated 180 degrees counterclockwise. So we're going to come down and first write down the ordered pairs for the new figure. So if you look at the graph, you can see that it would be at 6, -2, at 4, 2, and at 1, -6. And you can see that the points stayed in the same order, but they changed to the opposite of what they were. So that would be this last option down here. Okay, the square root of 100 is 10 because 10 times 10 is 100. And then the square root of 45 over 80, I'm going to simplify this by dividing them both by 5. So then I get the square root of 9 over 16, which would be 3 over 4. Okay, so we're going to be talking about dilations today. This is when a shape gets bigger or smaller. So some of you have been to the eye doctor and they put those drops in your eyes. So they dilate your eyes. They make the pupil bigger so that the doctor can see inside. So on this one, we are making the shapes either bigger or smaller, depending on what the scale factor is. So the first thing I'd like you to do is graph these points that are up here at the top of the page, just down here on the graph. So go ahead and do that on your paper while I'm doing it on here. Okay, now it says to make an image that is 3 times bigger. So in order to make something 3 times bigger, you're going to multiply everything by 3. Multiply all the ordered pairs by 3. So I'm going to take the ordered pairs that are up here at the top of the page, and I'm going to just multiply them by 3. So 9 and 6, -3 and 6, 3 and -6, and -6, -6. And then I'm going to re-graph it on the same graph. The shape should be the same shape, but they're going to be different sizes. So please graph this on your graph too. Okay, so you can see that they're the same shape, just different sizes. So the new one is 3 times bigger than the original one. Okay, so how do you know that it's 3 times bigger? Well, if you measure all the side lengths are 3 times longer. So I'm going to write down the original ordered pairs that they gave us at the top of the page. So this was 3 and 2, -1 and 2, 1 and -2, and -2 and -2. And then on the A prime part, I want you to write down these ordered pairs that we wrote off to the side after being multiplied by 3. So we'd have 9 and 6, -3 and 6, 3 and -6, and -6 and -6. So if you look at it, each coordinate has been multiplied by 3. And it says, why does this make sense? Well, it makes sense because the new shape is 3 times bigger than the original shape. Okay, let's keep going. If you need to pause the video at any time, you can. Just make sure you take notes while you're watching. So it says a dilation is a transformation that enlarges or reduces a figure, so it makes it bigger or smaller. The pre-image is the before. That's what you start with, and the image is the after. And then the scale factor, they use the variable k, and that's the number that it's getting bigger or smaller by. So on the previous example, the scale factor was 3 because it got 3 times bigger. To find the scale factor, you take the image and divide it by the pre-image. I like to think of it as doing new divided by old. Okay, so it says, with your partner, determine the scale factors created. So it's saying, what did you have to multiply the first point to get the second point? So you're going to take the new shape, so 6, and divide it by the old shape, and you get 2. And do that with the same thing on the y-coordinate. So 10 divided by 5 is also 2. So the scale factor for number 1 is 2, because you're multiplying the first one by 2 to get the second one. So pause the video and see if you can finish figuring out the other scale factors. Okay, so on number 2, you would do 6 divided by 2, and you'd get 3. 12 divided by 4 on the y-coordinates is also 3, so the scale factor is 3. So the shape would have gotten 3 times bigger. On number 3, so you'd have 5 divided by 15, which is 1/3, and then 1 divided by 3 is still 1/3. Notice that it started big and it went small, so your scale factor needs to be less than 1. So our scale factor is 1/3. And then on this last one, it's starting at 4 and going to 4, and starting at 6 and going to 6. So on this one, the scale factor would be 1. It's not getting any bigger or any smaller. It's staying exactly the same. Okay, question number 5 gives you a shape and then tells you what the scale factor is. So let's go ahead and draw the original shape. So I'm going to put A, B, and C on my graph. So please do that on yours as well. Okay, now the scale factor says right here that it's 2. So I'm going to take all the ordered pairs that they gave us, and I'm going to multiply them by 2. So A would become 6 and 10, B would become 0 and 8, and C would become -4 and -4. And now I'm going to regraph that on my graph. And you can see that I have the same shape. If I can draw a straight line, have the same shape. They are just different sizes. So the red one is 2 times as big as the blue one. Okay, let's look over here at number 6. Let's start out by just graphing the original shape. So please do that on your paper. Make sure you label your vertices, put the letters on all the corners. Okay, this one is telling you to make it 1/4 of the size. So we are going to multiply all the original points by 1/4. So the shape is going to be getting smaller because your scale factor is less than 1. So it'll be 0, -1, 0 and 1.5. 1, 1, and 1 and 1/2. So I'm going to regraph that, 0, -1, call it J prime. 1.5, I'm just going to put between 1 and 2. Let's see, 1, 1 is L, and M, kind of squeeze that in there. So you got this little tiny trapezoid that's inside there. So it's the same shape, just different sizes. So it's 1/4 of the size of the original shape. Okay, Riley is painting an art piece that is 16 by 24 inches. So she has some sort of piece of paper, 16 by 24, and she's copying her image. So it's coming from a little 4 by 6 like index card, postcard. So what is the scale factor of the dilation? So what does she have to multiply the postcard by to get the original shape? So from 4 to 16 or from 6 to 24, what did they multiply by? And you can see that your scale factor on this would be 4. So if you do new divided by old on both dimensions, 16 divided by 4 and 24 divided by 6, you're going to get 4. So she's multiplying by 4 to get the new picture. Okay, go ahead and turn to the next page, and we're going to look at some questions that you're going to see that are similar on your homework. This one says, for the figure, do a dilation centered at the origin with a scale factor of 3. Okay, so I'm going to start by writing down the ordered pairs for the original shape. So we got 2, 1, 4, 1, 4, 5, and 0, 5. If we do a scale factor of 3, that means we're multiplying every point by 3. So this would become 6, 3, 12, 3, 12, 15, and 0, 15. So go ahead and graph that on your graph. So you should have the same shape, just different sizes. This one that we're drawing now is going to be 3 times bigger because the scale factor is 3. Now let's answer the questions about it down below. So it says the shortest side of the original figure. So the original figure is the one that was printed on there, that was given to you at first. The shortest side is this one on the bottom, and it's 2. Now the longest side, the shortest side on the bigger figure is 6. Okay, so it's saying, what do you have to multiply this one by to get this one? So if you notice, 2 times what is 6? So 2 times 3 is 6. And then true or false, a dilation with a positive scale factor greater than 1 gives the final figure smaller. So if you multiply all the numbers by something greater than 1, your figure is going to grow. So this is actually false because you have a final figure that should be larger than the original figure. And then true or false, the original figure and the final figure are similar. That is true. That means that they have the same shape but different sizes. Okay, next page. This one also will be on your homework, something similar. So let's first start by looking at the ordered pairs for the original shape. So I got 0, 2, 4, 2, 4, 8, and 0, 8. Okay, I want you to use a scale factor of 1/2, so your shape is going to get half the size. It's going to shrink. So I'll multiply all these by 1/2 and get 0, 1, 2, 1, 2, 4, and 0, 4. Let's go ahead and put that on the graph. I'll connect those corners. So there's my new rectangle. Now this one is asking about area. So the area of the original figure, so the one that was given to you. So if we find the area of that, it's 4 by 6. So that area is 24. And the other one is 2 by 3. So that area is 6. So it's saying, what do you have to multiply your original one by to get the new one? So it is going smaller. I know some of you are going to say that it's 4, but if the scale factor was 4, that means it's getting bigger. So I'm going to do the new figure, the final one, divided by the old figure. Okay, so remember, new divided by old. And that's going to give me 1/4. So I'm multiplying by 1/4 to get the final figure. And then the true or false says the original figure and the final figure are not similar. So this is false. They are similar because they're the same shape but different sizes. Okay, pause the video if you need to, and then let's keep going. Turn the page in your packet, and let's look at these two triangles. So it's already been dilated for you, and it says that the scale factor is 1/2. So new triangle is half the size of the original triangle. So the first thing I want you to do is write down the coordinates, the ordered pairs for the final figure, for the prime one. So R prime is at -4, -3. S prime is at 1, 6. And T prime is at -5, -4. So then this next question is saying, how did they get from these original ones to the new ones? How did they get from the original to the final points? So if you look at all of them, all of the ordered pairs are half the amount of the original. And that makes sense because up here it tells you that the scale factor is 1/2. So I want to pick an option that has both the x and the y coordinates being multiplied by 1/2. So that's this second one down. Okay, go ahead and turn the page. This last page is combining all of the different types of transformations we've learned this unit. So if you need graph paper, there's some on the next page in your packet, but we're gonna just kind of run through these and see if we can do it real quick. So the first one says dilate with a scale factor of 2. So I'm gonna take the original shape and I'm gonna multiply it by 2. So let's see, I started with 5,3 and that would make it go to 10,6. Okay, when you reflect it over the y-axis, that means that the y stays the same and the x changes to the opposite, so that would make it -10,6. And then if I translate it 2 to the left and 4 up, that means I'm going to subtract 2 from the -10, so -12, and add 4 to the y, so that's 10. So my final point is -12/10. Okay, the next one starts with the point 4, -2. It's translated 8 to the right and 7 down, so I'm going to add 8 to the x, so that's 12, and subtract 7 from the y, so that's -9. And then dilate with a scale factor of 1/3, so that means I'm going to multiply by 1/3. That makes it 4 and -3. And then reflect it over the x-axis. The x stays the same, the y changes to the opposite. So that would be 4 +3. And again, if you're not sure, use the graph on the back of this page. It's there to help you. Okay, our last point is 7, -7, and it goes through these transformations. So if I rotate it 180 degrees around the origin, that just means that the points change to the opposite, so -7, +7. Translate it up 4 and left 3. So if I'm going left 3, that means I'm subtracting from the x. Going up 4 means I'm adding to the y. Reflecting over the y-axis means that the y will stay the same and the x changes to the opposite. And then translate 1 unit left and 1 unit down. That means each of these are going to get smaller by 1. And then reflect over the x-axis means that the x stays the same and the y changes to the opposite. So 9, -10. And if you're not sure about any of that, plot it out on this graph on the next page, and that will kind of help you visualize it a little bit more.